Welcome. In this video, we will take a look at understanding the difference quotient. Let's first consider the average rate of change of a function over an interval x to x plus h, where this little h value is some small value greater than 0. We can see that over this interval of the function, we have run 4 units of area. And if we consider the average rate of change of the function over this specific interval, I could write that as the following. F of x plus h, that functional value, minus f of x, that would be the rise of the function over that interval, divide by x plus h, subtract x, which would be the run of the function. Notice that the run of this function, that difference there, is just going to be h. So we could rewrite this as the following, with just the value of h, this small quantity larger than 0 in that denominator. And this is what we call the difference quotient. This is really important when transitioning our thoughts from average rate of change to instant rate of change, or the derivative function. So let's take a look at an example with this difference quotient for a specific function. So this example asks us to use the difference quotient, which we took a look at above, to find the average rate of change of f equal to x squared on the interval 2 to 2 plus h, where h is equal to 0.1 and 0.01. So we have really two problems to figure out. One, when our kind of small value h is 0.1, and a second when our h is 0.01. So let's consider the first case. The first case is when h is equal to 0.1. I would like to go out and find the difference quotient from 2 to 2 plus h. That would be 2 plus 0.1, which would just be 2.1. So we first want to find, again, the average rate of change of the function x squared over this interval. So let's consider that. If f of x is equal to x squared, we could say the functional values here, f of 2 is equal to 4, and f of 2.1 you can find to be 4.41. Those are the components that we want to use to find the average rate of change over this interval. So let's put it all together. We know that the average rate of change over this first interval is going to be equal to f of 2.1 minus f of 2 divided by, for our difference quotient, we just divide by the value of h. And in this case, our value of h is 0.1. So let's follow through with this calculation. We have 4.41 minus 4, and then divide by h, which is 0.1. When we do so, we'll find that this difference quotient gives this average rate of change to be 4.1. And that would be the first part of our problem. Let's take a look at the second difference quotient. We'll take a look at when our h value, the distance between x and x plus h, is 0.01. So here we're going to be finding the average rate of change over the interval starting at 2 to 2 plus h, which would give us 2.01. So again, I already know my functional value at 2. My functional value of 2.01. This can be found by just squaring this value again. If you square this value, you should come up with 4.0401. And again, here is where h is equal to 0.01. So again, let's follow this equation through. We'll have the average rate of change of our function from f of 2.01 minus f of 2 divided by, here, h, which is going to be 0.01. So to finish this up, we know our functional values. And if we put this into our calculator and make this calculation, we'll find that this average rate of change over this interval will be 4.01. In our next video, we'll take a look at analyzing these results and make a conclusion and relate it to the idea of instant rate of change.